come back to our electrical machine lab 2, especially in 5th semester. So now we go for another experiment, especially on single phase induction motors. So all of us know that induction motors are classified as based on the phase, that is 3-phase and single phase. So we have 3-phase synchronous, 3-phase induction motor and single phase induction motor. So now we have one experiment on single phase induction motor, that is no load and rotor block test on single phase induction motor. Induction motor, single phase induction motor performance can be obtained by conducting two tests, that is no load test and rotor block test. So in this particular experiment we are going to determine the equivalent circuit of single phase induction motor. So for this, no load test and rotor block test are to be conducted. So before going to conduction of experiment, we will see the circuit diagram related to single phase induction motor and no load test and rotor block test. So if you see, so this circuit diagram shown is no load test on single phase induction motor circuit diagram, where we have input supply, then that input supply 230 volts is directly given to the single phase induction motor. This is single phase induction motor, where it shows M1 M2 as the main winding and S1 S2 as auxiliary winding, and rotor winding is, since it's a squirrel cage type, so it is shown as a circle with some small circles inside this. So this rotor is a squirrel cage type, so no need to worry about that. And of course this combination, you can see here a switch along with a capacitor. This combination will act as centrifugal switch, and of course one capacitor here. And this is the SPST switch we need to include in the circuit in order to operate under no load as well as no load, load conditions, that is short circuit conditions. So for this induction motor we need to measure the current, voltage and the wattage, that is wattmeter readings. Hence we are going to take 3 readings here. So 3 measuring instruments, one is ammeter here, voltmeter and a wattmeter. So under no load condition, normally the induction motor will take current, we assume that current will be less compared to rated conditions. So accordingly we will go for taking down the nameplate details. Before that, first we see the voltmeter common is connected to phase, voltmeter other end, that is 230 volts range, is connected to neutral, and ammeter range should be based on the nameplate details. Is it clear? So that nameplate details will take shortly. And this is the wattmeter, in which it has 2 coils, that is ML as the current coil and CV as the potential coil. And since we are going to use a single phase wattmeter here, M and C should be shorted. So CV is connected across the supply, and ML, that is current coil, is connected in series with the induction motor. So S1 S2 are starting windings. Another name for this is auxiliary winding. M1 M2 main winding, or otherwise we call it as running winding. Okay, a capacitor is included in the circuit to improve its power factor, and there is a centrifugal switching action that takes place within the motor, and the SPSC switch is included here to operate this machine both on no load as well as on rotor block condition. So before going to connections, we will see the nameplate details. Based on that, we will decide the ratings. So these are the nameplate details of single phase induction motor, where its power rating is 1.5 kilowatts, voltage 220, amperes 14, and RPM 1440 RPM. Armature winding resistance will be 1.2, and radius of the brake drum. If you want to go for brake test on low load induction motor, single phase induction motor also, the drum is included along with mechanical loading arrangement. You can see here, and the nameplate details are also shown on actual nameplate details on the machine. You can see here amps 14, RPM 1440, and wattage 1500 watts, nothing but 155 kilowatts. Apart from this nameplate details, you can see the brake drum arrangement. Whenever you want to go for conducting load test on this, so you can have a brake arrangement. Once if we have the knowledge of the nameplate details, then we can go for noting down the ranges, that is 0 to Since the maximum current rating is 14 amperes, we can go for 0 to 20 amps as range and MI instrument. And the voltage 0 to 300 volts and MI. So, and coming to the wattmeter rating, so we can take 20 amps, 300 volts and LPF wattmeter, because we are going to conduct this machine under no load condition. So, we need to go for LPF wattmeter here. So, once if you go for finalizing the nameplate, that is ratings of the instruments, then we go for connections here. Based on the circuit diagram, you can see from the line, that is from the base, one wire is connected to voltmeter common and another wire is connected to M as shown in the diagram. One is connected to common and the other one is connected to M. And L is taken to ammeter other end as shown here. L is taken to ammeter common, so it is shown here common. And ammeter other end is connected to M1, that is main winding or running winding. Is that clear? And since it's a single phase instrument, so M and C are both are shorted. And voltmeter other end, that is 300 volts, the black wire, and 300 volts from wattmeter as shown here, they are connected to the neutral, that is the return path of the supply. And for the same neutral, one more winding is also connected, that is S2, nothing but S2, M2, all these are connected to neutral. You can see here S2 and M2 shorted and S2 is connected to neutral, and voltmeter other end and wattmeter 300 volts both are connected to neutral. So this finishes the windings. And from S1, that means you can see here from ammeter other end, there where we have ammeter other end here, it is connected to M1 and M1 is connected to one switch across as shown here, that is one switch terminal, and the other switch other end is connected to S1, that is starting winding or auxiliary winding. So this finishes the connections for single phase induction motor under no load condition. So now we will see, let us start the induction motor by turning on the DPST switch as shown here. So once a PG is supplied, you will see the motor is running. The motor is running. So that now we can see the motor is running condition when this DPST switch is turned on. Please observe even the current rating, voltage rating and wattmeter rating under no load conditions. So voltmeter rating, it is showing V0 as 240 volts and current it is showing as 5.8 amperes, 5.8, and it is connected to 20, hence multiplied by 2, so that gives you 11.6 amperes. And wattmeter rating, you can see here, it is showing 96 watts. 96 watts. And the multiplying factor for this, you can calculate by seeing this the meter, or even you can see here for 20 amperes, 300 volts, it is showing 400. So multiplying factor will be 96 into 4. Or else even you can calculate here, since the voltage connected is 300 and the current considered is 20 amperes and power factor is 0.2, therefore 300 into 20 into 0.2 divided by the least scale reading, that is 300. Even in that way also you can calculate the multiplying factor as 4 for this particular no load test. So finally the voltage rating is 240, current rating is 11.6 amperes and wattage rating is 384 watts. So this is for no load test. Similarly, we will go for conducting rotor block test for this single phase induction motor. Students, now let us go for rotor block test on single phase induction motor. Before going to that, let us see the circuit diagram as shown here. This is the circuit diagram related to rotor block test. You may observe or there may be a confusion. If you see, this is rotor block no load test, wherein which the space switch is in closed condition. Now, in this case, the space switch must be in open condition. Then only we will be getting no, that is rotor block condition. And coming to the other parts, other changes are we are going to add an auto transformer, and the ranges of these voltmeters are getting changed. So we'll go for 0 150 volts MI, and of course current rating 0 to 20 amps MI, and 20 amps 150 volts UPF wattmeter. So for load test, rotor block test, we are going to consider UPF wattmeter, not LPF. And auto transformer is added because you need to vary the voltage in such a way that you are going to get rated current in the ammeter, because rotor block test is to be conducted under rated conditions. So this is, and the remaining aspects are all same for the single phase induction motor. Now coming for operation. So simply let us see that this is auto transformer, where the input is given to auto transformer as shown here, and from the output all these meters are connected as per the circuit diagram. And see that this should be in zero conditions, and let us give voltage here, DPS switch is given, turned on, and slowly we have to vary, the auto transformer knob in such a way that we will be getting rated current as shown here. And please see here, the switch should be in open condition. Slowly vary this until you get 14 amperes. Since it is connected to 20 amperes, the reading is showing 7. So 7 into 2, that is 14 amperes. This is what the rated current that is applied for the induction motor on rotor block condition. Now we have to note down the readings for rotor block test. Rotor block test on single phase induction motor. So where we will be getting VBR and IBR. BR represents rotor block conditions. So voltage is showing 150 volts, so it is 82 volts here, and block rotor current, it is showing 14 amperes, nothing but rated value. And wattmeter rating, please observe, it is showing has some 310 watts. And the multiplying factor for this one is just like what previously we have done. You can show for 20 amperes, and 300 volts. Okay, I think this is not clarity, but you can see here voltage rating is 150 volts, current rating 20 amperes, 150 into 20 is into unity power factor VI cos phi divided by the least scale reading. So 150 into 10 watt, 1500, and divided by 1500 into 1 and divided by 750 is the full scale deflection. So 1500 by 750 is what? 2. Multiplying factor for this is what? 2. Therefore, you will be getting 620 watts as the block rotor condition power measurement. And this one is 14 amperes and this one is 82 volts. So this gives us the rotor block test results on single phase induction motor. So this finishes the experiment on rotor block test on single phase induction motor. Again, reduce all the values and then turn off the switch. DPST switch is turned on. So once if you note down these readings, then from no load test and rotor block test, we need to do some calculations, and based on that we will be determining the equivalent circuit parameters of a single phase induction motor. So this finishes no load test and rotor block test on single phase induction. That's it. Thank you very much.